everyone, so welcome to my channel Chem Kamal. So I am Kamaldeep Kaur, a chemistry teacher. From today onwards, I am going to upload the videos on chemistry syllabus class 12th. So if you are new to the channel, kindly subscribe it and follow the channel for more updates. Okay, let us begin. So you all know that in class 12, the chapter 1 is solutions. So it is chapter 1 and our first topic uh, is concentration terms. So I am going to teach you about concentration terms in details. So let us begin. What do you mean by concentration? So concentration basically defines how much solute, how much your solute, which may be in terms of mass or volume, present in given amount of solvent. Present in given amount of solvent. Again, solvent can be taken in terms of mass or volume. So concentration terms are many. So there are many ways to express the concentration terms, that is to define the concentration of a solution. We can use various terms such as molarity. We may also express in terms of molality. Of course, molarity is denoted by capital M and molality by small m. Then we can also calculate it in terms of mass percentage. We can also calculate in terms of volume percentage. We can also calculate it in terms of mass by volume percentage. Then we can also talk about mole fraction. Mole fraction is also one of the concentration terms. Then after mole fraction, we have ppm, which stands for parts per million. So these are the total concentration terms which are there in the NCERT and in your syllabus. We don't have normality. We don't have other concentration terms which might be there in the refreshers. So all this is pertaining to your NCERT book only. So these are in total 7. So we'll take them one by one. We will see the definitions first, their units first, and then we will be solving the numericals later. So first concentration term is molarity. I hope you already know what molarity is. Molarity is defined as the number of moles of solute. So number of moles of solute when divided by volume of solution, when divided by volume of solution in liter, it gives us the molarity of the solution. So basically in numericals, we are not given number of moles generally. So number of moles are calculated as the given mass. So many times we are given the given mass when it is divided by the molar mass of solute. So both the things are for solute only. So number of moles of solute now. So we'll calculate N by dividing given mass to the molar mass of solute, and volume may be given in terms of volume is often given in terms of milliliter. So when milliliter is divided by the given value of milliliter, say 250 ml. So 250 ml can be converted into liters by dividing with 1000. Okay. So conversions can be done, of course. So basically molarity M is equal to number of moles upon volume in liters. This is the main definition, but N can be replaced by W upon M. Beta, what is W? W is given mass. And M stands for molar mass here. Now volume is always in denominator taken. So if volume is given in milliliter, no problem. So when you divide milliliter by 1000, it will go in the numerator and get multiplied. So why not to write this 1000 in the numerator directly? So this is the molarity equation. Now, what are the units? Units are important when you calculate the answer. So with the answer, you can write capital M or simply the units with the value mole per liter. Okay, mole per liter. Mole in unit is written as MOL only. We omit writing E. So mole per liter are the units of molarity. So this is the first concentration term. And you can see molarity depends on volume of the solution. Okay. So next concentration term second is molality. So molality is small m. It is again equal to number of moles of solute, but here we take the mass of solvent in kilogram. So here mass is taken, that too in kilogram, but if mass is given in gram, so we can convert it into kilogram easily. So molarity is equal to n upon number of moles are n, and mass is in gram is given, no problem. ऊपर ले जाओ 1000 को, then you can calculate molality in this manner also. Okay, again n is equal to W upon m, we already know, given mass of solute divided by molar mass of solute into mass of solvent in gram. So we don't require the mass of solution, we require the mass of solvent in gram. Okay, multiply by 1000. So molality can be calculated in this manner. So it depends on the numerical which equation has to be used, either one or second. Both are equally applicable. And if we talk about the units, units may be up. Along with the answer, you can write the simple small m, or with the answer, you will be writing mole per kg. Fine. I hope you have understood these two. Now coming to the third one. Third concentration term is mole fraction. So ये भी आपने 11th क्लास में किया हुआ है. Mole fraction is denoted by the letter chi. ठीक है, इसको बोलते हैं chi. It is not x, it is chi. So mole fraction of both, that is solute and solvent. Solute and solvent. So in a solution there are basically two components, na, solute and solvent. So we can calculate mole fraction of solute or mole fraction of solvent. If we denote solute as A and solvent as B, so mole fraction of solute is equal to number of moles of solute divided by number of moles of solute plus number of moles of solvent. Okay, mole fraction is a fraction basically of moles of that component to the total moles. And similarly, mole fraction of B will be equal to number of moles of B, that is solvent, divided by total number of moles. So total will remain in the denominator always, and mole fraction जिसकी भी आपको component की निकालनी है उसी के number of moles in the numerator, the total number of moles when divided gives you the value of mole fraction. So mole fraction is the dimensionless, it has no unit, it is dimensionless quantity. So इसका कोई unit नहीं होता. Moreover, a point to be noted that mole fraction of all the components. So इस solution में हमने assume किया कि एक solute है एक solvent है, but solution में दो solute भी हो सकते हैं ना, but generally solvent एक ही होता है. Solvent is always one, solute can be more than one. Like in lemon water, you add sugar, salt, pepper, etc. Lemon juice आप add करते हैं water में, तो ये सारे sugar, salt, pepper, lemon juice, these are your solute, and your water is solvent. So basically solvent is always one and solute can be more than one. So आप मोल फ्रैक्शन किसी भी कंपोनेंट की निकाल सकते हो डिवाइड करके उसी सब्सटेंस के नंबर ऑफ मोल्स टू द टोटल नंबर ऑफ मोल्स. नाउ द पॉइंट इज मोल फ्रैक्शन का जो सम होता है सभी कंपोनेंट्स का, दैट इज always equal to 1. So आप number of moles of A plus number of moles of B का आंसर निकालोगे, that will not be exceeding the value 1. Even if there are three components, Na plus Nb plus Nc plus so on, कितने भी component इसमें डाले हो आपने, कितने भी substances डाले हो, तो उनका sum हमेशा 1 ही आएगा approximately. It may be 0.99, that is again equal to 1 almost. So mole fraction is your third concentration term. Now moving on to fourth concentration term, that is ppm, parts per million. Parts per million. Now this concentration term is used when we know that the concentration of solute is very less. When concentration of solute is in traces or very low in given solution, then you use ppm. Like in air में जो pollutants होते हैं ना, pollutants in air, they are measured in terms of ppm. ठीक है, pollutants को report किया जाता है air में, that is the harmful particles present in the air which causes pollution, they are reported in terms of ppm because their concentration is very low. ठीक है, तो अब now what is ppm, how it is calculated? ppm में आपको क्या करना है, ppm में आपको mass of solute which whatever is given, mass of solute ले लो, divide करो उसको given mass of solution whatever is given to us, and when you multiply this both by 10 raised to power 6, 10 raised to power 6 means 1 million. So you ultimately get the answer in your parts per million, that is out of million part you will be calculating the answer. Okay, so Now, we have a NCRT problem also based on this, not NCRT problem, basically an information. It says that the amount of dissolved oxygen, so amount of dissolved oxygen जो होती है ना sea water में dissolved oxygen होती है 6 into 10 raised to power minus 3 gram in total 1030 gram water में. So if mass of water is 1030 gram, in this, the amount of oxygen which is reported is 6 into 10 raised to power minus 3 gram, which is a very low value. And we will be reporting this all in ppm since mass of solute is very less. So when you calculate this information in ppm, so amount of oxygen present is 6 into 10 raised to power minus 3 in 1030 gram water and multiply it by 10 raised to power 6. The answer comes out to be 5.8 ppm. Okay, 5.8 ppm means in million parts of water, in million parts of water, amount of oxygen amount of oxygen is 5.8 parts. ठीक है, मिलियन पार्ट्स में ऑक्सीजन पार्टिकल्स होंगे 5.8 parts. This is very very low number. Thus ppm is used to express the concentrations in which the solute amount is very low or in traces. So I hope these four definitions are clear to everyone. Now the next concentration terms and the numericals will be explained to all of you in my next video. Thanks for watching. Do like the video. See you next time.